So this is problem 39 of chapter 13 of Giancoli 6th edition. So we have a certain amount of oxygen. So we have a certain initial volume of oxygen. This is given at a certain initial temperature. So we also have T1. Careful, T1 is given to us in Celsius. So be sure you put this temperature in Kelvin. Okay, and they also give us the initial pressure, and the pressure is given in absolute, is the absolute pressure, so we are good. Okay, and then what we are going to do is we are going to compress the volume. So we'll reduce the volume, get a new V2, okay, and at the same time the temperature will raise. We'll get a new T2. Okay, all this is given. Again, this T2 is given in Celsius, so be sure that you write it in Kelvin. And we want to know what is the new pressure. Okay. Well, the R, the constant, is nothing happens to it, and we are assuming here that the number of moles, the amount of this oxygen does not change. Okay, so what we have is initially this is an ideal gas, so we have P1 V1 equals to nR T1, but I'm going to write it like this. Okay, this is what is not changing. On the other side, after we compressed this volume, we'll get P2 V2 equals to nRT2, but I'm going to put this T2 here. This is constant, so this and this is just the same. So I just can play with this ratio. I have P1 V1 divided by T1 is equal to P2 V2 divided by T2. Okay, so from this we are going to find this new P2. In which unit? The same unit that we are using for P1. Okay, what we have to be careful, the temperature has to be in Kelvin. Okay, do not keep it in Celsius. Now the volume is given in liters, both one, V1 and V2, so that's fine. We'll have a ratio of the same units, this is good. Okay, but for the temperature you have to change it and write it in Kelvin. And why is that? Well, look, you will say, but I'm also playing with a ratio for the temperatures. Let's have a look. T1 divided by T2. Pick two arbitrary temperatures, okay, and write it, for example, in Celsius. So let me suppose that my initial temperature is 20 Celsius and the final temperature is 40 Celsius. This gives us 2, okay? You will see that this is very different from 20 plus 273 divided by 40 plus 273, okay? This is not going to be equal to 2. Okay, so when you're writing the temperatures, you have to write it in Kelvin. So let's write this with big letters here, big capital letters here. You have to put it in Kelvin. And that's it. That's how you solve this problem.